going to kill you. All right, can everybody online see my screen?
Yes.
All right, thank you. All right, let's go ahead and start chapter 7. We're now going to look at the last part of the number system, decimals. Real numbers, the last part is we've talked about fractions, we've talked about multiplication, fractions, we've talked addition, subtraction, fractions. Now we're going to look at decimals and how they work. Normally in education, fractions are introduced last. You first talk about proper fractions, then you introduce improper fractions, and then lastly, we now convert them to decimals. So, what is a decimal? The name itself tells us. The first part of the word decimal, deci means tens, tenth. Our counting system, our number system that we deal with is base 10. So with decimals, we have a dot. This dot differentiates between numbers greater than 1 and numbers less than 1. Now remember, we have a base 10 system to begin. Anything to the 0 power is 1. So in our numerical system, bless you, everything to the left of the decimal has its own tens column. Remember, these exponents, what they represent is the number of zeros after a number. So if I had 10 to the power 0, how many zeros are after the 1? None. There's 0. If it's 10 to the first, there's 1 0. If it's 10 to the second, there are 2 zeros, and so on and so forth. So that's moving to the left. The farther a number is to the left, the bigger it is. Now, if you notice, let's go to the right. Notice how the exponent decreases. What comes after 0? Comes negatives. So what these negative numbers mean is we now have fractions. Again, the digit, the integer, tells us how many zeros we have after the 1 on the bottom. So for example, the number 128.965. And if we line up the decimals, there's a decimal. We have 9, 6, 5 here, 8, 2, 1. So what does this number really look like? Well, it looks like 1 times 10 to the second power plus 2 times 10 to the first power plus 8 times 10 to the 0 power decimal 9 times 10 to the negative 1 plus 9 times 10 to the negative 6 or negative 2. Oh, sorry, that's 6. I'm sorry, 9. Plus 5 times 10 to the negative 3. Oh. 10 to the power 2 is 100. So what I'm getting to is, with this is we relate back to what we did in the beginning of the semester. When we looked at what do each of these numbers mean. Now, the only difference is we now have smaller numbers here. So what is 10 to the power negative 1? 10 to the power negative 1 is 1 over 10, which is 0.1. So it's 0.1. 6 times 10 to the power negative 2 is 0.01. Plus 5, and since it's negative 3, now, what am I trying to show here? If it's a positive integer, if the power of your exponent is positive, that means after your number, after you do the multiplication, you have that many zeros going to the right. But when you have a negative exponent, you move to the left. So 9 times 0.1 is 0.9. So it used to be 9.0, now it's 0.9. 6 times 0.01 is 0.06. 5 times 0.001 is 0.005. So what do you notice here about the numbers? Every step we go further to the right, we have more numbers after the decimal. But how many zeros in front of the decimal or behind the decimal? 5 was to the power negative 3. It only has 2 zeros. 6 was to the power negative 2. It only has 1 zero. 10 to the power negative 1 has no zeros. So what can we conclude there about those kind of numbers? Why on this one has 2 zero up here, so I have 2 zeros behind it. This one has 3, a negative 3, but I only have 2. Why is it not the same number of zeros?
It is because of the placement of the decimal.
What do you mean?
So if the number is like in front of the decimal and it is moving to, let's say, the right twice, moving the decimal twice will make it into being 100. Well,
So what determines where the decimal starts?
the decimal will always start behind the number.
Did you ask your question again?
What determines where the decimal starts?
It always starts behind the one place.
What about this one? 0.965.
It always starts before the tenths place because of the name.
Not tens.
No, the tenths places.
Here's the ones. This is the tenths. There's where the decimal is. Yes, what you're trying to say is this. Any number can be written as a decimal. How would you read that? Oh, actually, how would you read this?
43.2.
Okay, that's one way. What's another way of reading it? We've now given this another name from decimal to a point. That's how you would read it. 43 and 2/10. The older generation used to write checks. We used to know this stuff. And nowadays it's just point. It's not really ever read like it's supposed to be read. How would you write this number down?
1 and 345,000.
Are you sure? There's a decimal, 1. And you're right. This number is what? 345. But since it's a decimal, you always write it with respect to the last decimal. This is the tenths, hundredths, and this is the thousandths. You're right. So this is 1 and 345 thousandths. So the last word, whenever you write it or describe it, is always in reference to the last digit, non-zero digit to the right. How about this one? Got it?
2 and 10,000 and 3,000? 10,000.
Yeah. 2 and 3 10,000ths. Because this is the tenths. This is a hundredths. This is a thousandths. And this is the 10,000ths. Let's look at some examples. How would you use manipulatives to teach this stuff? Remember, things have now changed because
What if you change the value of manipulative?
yeah, what would this number be originally for kids? How many?
Oh,
It used to be 1 unit
And these are,
and
no, there's just count how many of them are. And there's one of those. So this is the ones. This is the tens. This is the hundredths. And this one is the thousands. So this number is 1,000 plus 100 plus 20 plus 3. So it's 1, 1, 2, 3. That's what they remember because that's what we start off the first part of the semester. Now we can't use those anymore. We have to change their values because now we have to go to the other side of the decimals. How would you write this in manipulatives? See, now things change. We would save one of these type of examples for later on, much later on, because what we'd have to do first we have first define a number like this. So in manipulatives, how much is that worth now?
which in the unit or unit?
Well, think of what we have. Remember, we're dealing with decimals here. So how many of them are in this long?
10.
So each one of these inside there is how much?
1, 10.
This would be 10 tenths. So that's a 1. And then we have 100 tenths. So this is tens. So as you go on and defining much smaller numbers, you have to start defining what kind of numbers these are. So 5.4. Using this number is represented how? 5 of these. So we have 5 longs. And there's our decimal. And now we have 4 tenths. Yeah, so it becomes a lot more complex when we start looking at these. Converting fractions to decimals. How do we do that? Well, one thing we have to do is make sure that we know what
The difference between them.
we first have to introduce, because they're to the right of the decimal. If it only has 1 0, remember, and you also told them every number, that's a 2, it has a decimal and then a 0. Every number. So, if it's divided by 10, it becomes 0.2. Every 0 on the bottom moves to the left, one space. So there's our 2.0 on top. But now we divide it by 100, so we move it 2 to the left. So it becomes 0.02. This is 2.0, but it's got 3 zeros on the bottom, so we got to move it 1, 2, 3. And so on and so forth. That we have to introduce that first. And then we'll throw in something like this. How would you rewrite this? Because once they understand this concept, count the number of zeros on the bottom. That's how many decimal places you move which direction? To the left. So we move it to the left one. So our answer is 4.335. Okay, once you understand this, now we have to be able to go both directions. There's a decimal. How would you write that as a fraction? Again, stop thinking as a college student. I want you to start thinking how you would show these two, what's going through the kids' heads. Yes, you're answering like a college student. Yeah, it's pretty easy. It's algebra. You've had 12 years of this stuff. But how would you instruct this to the kid?
Or I guess,
Well, we refer back to what we just did. 2 over 10 is 0.2. So every time we move the decimal, we have a number to the left. That's how many zeros on the bottom. So what our objective is, we want to get a number, this number, so it doesn't have any decimals. So to go from here to here, what do we how many spaces do we move it? We move it 1, so we have to divide it by 10. There's only 1 0. You have to make those connections to the students. You can't just throw them in there, tell them what you know, and impress them. You'll just confuse them and you'll lose them. So here we have, now, remember we talked about division. Is that a good answer? Oh yeah, this is improper because the bottom is smaller than the top. So how many times does 10 go into 53?
Mm,
10 times 5 is 50 with 3 left over. So it's 5, 3 over 10. Because now what you could do, you could make this connection here. There's another connection you can make. Remember how we used to expand mixed numbers? We expanded mixed numbers by adding the integer and the fraction. Because remember, you're trying to make a connection. So if you have a 5.3, you can also say that 5 plus 3/10, because I only have one decimal place. And since it only has one decimal place, that's where decimal came from. So that's what 0.3 really is 3/10. How about 0.02? How would you do this with them? So there's the non-zero number. How many spaces do we move to get rid of the decimal?
Twice.
1, 2. So that means we have to have 2 zeros on the bottom. Are we simplified? No. Why not?
2 can be divided out on the top and bottom.
Right. Because 2 goes into 10 how many times? 5 times with 1 0 at the end. 2 goes into 2 once. What is 1/5?
0.2.
Why is it 0.2?
Is if you multiply the 5 by 20 to make it into the hundreds place, you'll be able to get the amount to the.
Actually, and we're going to get to, that's one way that your teacher taught you, but there's an easier way than that. But yes, yes, I know exactly what you're talking about. Because you multiply, try to get 100 on the bottom, but there's a much easier way than that. That tells us about if we have a finite number of decimals. But yeah, so this equals 0.2. There's a 0.2. And what else do we have to do? We have to go one more step further. So we have to go from there. One more decimal is to the left, 1/10. So what we could look at here is we have 1/5, this times plus 50 is made up of 5 times 10. Yeah, so again, in mathematics, there's always more than one way to solve the answer. So if we just wanted a fraction from this decimal, that's what we do. But we have to explain to them what it means. How about this number, 2.013103? Give me a fraction equivalent for that one. Think of what we did here for the 5.3, what it meant. Can we do the same thing here with this one? Do we do anything with the 2? Nope, it just stays there. It's not a decimal.
Because the rest will be making into a mixed number.
Yeah, because now we have this whole number here.
It's in the thousands.
Well, that's
10,000.
103. We could put a 0 in front of there, but you never want a leading 0. So what's on the bottom? We have 10, 100, 1,000, 10,000. And there's your equivalence. As a mixed number, what would it look like as an improper fraction? Very good. 20,103 over 10. Very good. Because now you can connect to them. Say, here's our decimal here. We divided by 40, so we move it, made the top and divided by 10000. All right, I want to give you 3 examples. You guys convert them into decimals for me. So we have 25 over 10. What's that going to be?
2.5.
Why?
Because the 20 needs to go into 10 twice, while being 5 over 10, which is half.
Which is 2.5. Or remember, as I said, since there's a 0 on the bottom, you move the decimal 1 to the left. $56 over 100. Where's the decimal in 56? Behind the 6. So since I'm dividing by 2 zeros, which direction does it go? To the left. So it's 0.56. 205 over 10,000. Point 205. Let's see. How many spaces do we move it? So from here, 1, 2, 3, 4. Point. Yep. And besides, there's a way we can check it. Remember the rule of the definition of fractions, of division? If A over B equals C, then A equals B times C. True? If I multiply both sides by B, so in order for a fraction to work, this has to be true. So let's look at 25 divided by 10 was 2.5. So that's what we have here. That's this part. How do we check it? If we take 25 and take 2.5 times 10, which direction do you move a decimal if you multiply by 10? To the right. Of course, I'm talking about the decimal. Move the decimal. Why? Why, when you divide, you move it to the left? Why, when you multiply, you move it to the right?
Taking away a tens place.
You're making it smaller. When you divide, you make things smaller. So what happens? The decimal moves further to the left. When you multiply, it makes it bigger, so it moves it to the right. Ooh. Okay. Express as a decimal. Because so far, whenever we have a 10 on the bottom or 100 or any factor of 10, isn't it a lot easier to move the decimals that way? That's what we're going to do here. If you can make the denominator a factor of 10, then it will make the whole number easier. Okay, what does that mean?
So we have to try and have the
10 is made up of 2 times 5. $100 is made up of 10 times 10, or 10 squared, right? But what is 10 made up of? 10 is made up of 2 times 5. So if you can formulate the number on the bottom so that it's a factor of 10, it makes it much easier. So 10,000 would be 10 to what power? Count the zeros. 1, 2, 3, 4. So it's 10 to the fourth. 10 is 2 times 5 to the fourth. By the exponential rules, so whatever you have to do to make the bottom number a factor of 10, you can do it. So look at this one. What do we need to make a bottom a factor of 10?
506.
Right, we need 6 5s. So you can't just put it on the bottom, you have to put it on top also. So to write this as a decimal, let me see. This makes you need a calculator, so it's going to be 0.0 That's that top number. Because it's 5 times 5 times 5 times 5 times 5 times 5 times 7. And on the bottom, we have 2 times 5 to the 6. So it's 10 to the 6. What does 10 to the 6th look like? So it's a 1 with 6 zeros behind it. You notice how this number and this number are the same thing. So when you have 6 zeros, how many spaces in which direction do we move the decimal? Yeah, move it, since there's 6 zeros, move it to the left 6 times. Well, now we do this. Now we see this. If we have a base 10, move it 6 spaces to the left. So there's a decimal. 1, 2, 3, 4, 5, 6. And there's your answer. So if you can make the bottom a factor of 10, it makes it a lot easier. How about this one? What are we missing?
One more exponent for the two.
We're not missing an exponent. We're missing one more 2. The exponent tells us how many we have. This one says we have 3 2s and 5 and 4 5. So we're missing one more 2. So we have to multiply top and bottom by what? 2 to the first power, yeah. So we have 2 to the third times 2 to the 1 makes it 2 to the fourth, which makes it 10 to the fourth. So we move the decimal 4 spaces to the left. So it's 1, 2, 3, 4. Oop. How about if I gave you this? What would you do? Factor the denominator. So you get 125. Since it ends in a 5, we know it's divisible by 5. 5 goes into 12 how many times? Twice. With how many left over? So 5 goes into 25 5 times. 25 is 5 times 5. So our denominator is 5 to the third. What do we need to make it a base 10? We need 2 cubed. We need 3 2s. So on the bottom we have 10 cubed. On the top we have 2 cubed. What is 2 cubed? 8. So move the decimal 3 to the left. 1, 2, 3. So our answer is and the last one for this example, same thing. $250 is 25 times 10 because it ends in a 0. 25 is 5 times 5. 10 is 2 times 5. So we have 3 5s and 1 2. What do we need to make it a base 10?
2 squared.
Yeah, we need 2 more 2s. Since there's 3 5s, we need to have 3 2s. We're missing 2 more. So we have 2 to the power 2. So on the bottom, we have 10 to the power 3. 2 squared is 4, so it's 28 over 10 to the power 3, which is 28 with decimal here. 1, 2, 3. So the answer is 0.028. Notice that each of these decimals were finite. They didn't go on forever. That's called a terminating decimal. A terminating decimal is a decimal that has a finite number of numbers. It doesn't go on forever. There's a theorem for this. A rational number, a over b, in its simplest form can be written as a terminating decimal if and only if remember, IFF means if and only if the prime factorization of the denominator has no other primes other than 2 or 5. If you factor out the denominator and it has other numbers other than 2 and 5, then you cannot be sure it's going to be terminating. It's not going to be terminating. It could repeat itself forever, or it could be multiple different numbers. So is that going to be a terminating decimal? Will this number be terminating decimals? Determine if this decimal is terminating or not. Well, again, in mathematics, I don't like when students just spit out an answer without thinking. Because there was zero thought. I finished asking the question, there was a yes or no. No, never do that. Never answer a question, period, in your life without taking time to think about it. Factor out the bottom. What does 8 break down into? What is 4 made up of? Is there any other number on the bottom other than 2 or 5? No. So it is a terminating decimal. Because all I would need to do is multiply by 5 to the third. Now it's a terminating decimal. Again, I never want to hear any answers unless you think about it. How about this one? What's 250 made up of? 25 times 10, 5 times 5, 2 times 5. So it's 2 to the first, 5 to the third. Yes. So it's terminating. How about 21 over 28?
It isn't terminated because its factors are 2, 7, and 2, 5.
It is a terminating. Remember what the thing said. The theorem said a rational number a over b in its simplest form. In its simplest form. 28 is made up of, so 7 times 4, okay, 7 times 4, which is 2 and 2. 21 is made up of 7 times 3. Can anything cancel?
Only this.
So what do we have now? Now it's only a denominator of 2 or 5. So it's terminating.
How'd you get the 5 squared part?
Because in order to make 10 on the bottom, this is 2. What times 2 squared gives me 10? 2 times 5 is 10. And they're both power 2. Because 37 is a prime number, and 768 has more numbers than 2 and 5. Ordering decimals, placing them in order of smallest to largest. When comparing decimals, compare each term by term. I'll show you what that means in a second. Until one term is not equal to the other. Comparing these two, which one's larger? Line up the decimals. The zeros are the same. The 2's are the same. The 3's. Oh, now it's a 1 and a 2. Which one's bigger? This one's bigger. That's why you compare term to term. As soon as you get to one that's not equal, then you're done. All right, let's move on to the next topic. End of section.